This was just an idea that came from when I was about 12 years old, and we lived at the head of Haynes Inlet, and from my bedroom window I could look down on the dock, the old dock when the mail boat used to come up there, and the tide would come in, and the dock would go up and the tide would go down, and I thought in those days there must be some way to hook that up so I could get some kind of power out of it as it's going up and down against the piling. And that was 65 years ago or 70. And I finally, in my retirement, I just started putting this thing together, and there's no engineering in it. I put it together like a millwright would put something together, and all it does is take the vertical oscillating motion of the tide and convert that to a unidirectional rotary motion and steps it up, in this case about 200 times. The way it works, it hooks to the top of the piling, comes down through this fair lead. There's an idler sprocket here, comes around a drive sprocket, down around another idler, then goes down to the bottom of the piling, and it's hooked to the bottom of the piling, something like what I have on the top of the piling. And as the dock goes up and down, it turns this drive sprocket this way or that way, and that and like I say, this one has these spur gears which make one of these clutches go backwards while the other one's going frontwards, and it makes the end drive clockwise all the time. The problem is Newton had figured this all out, and he said that you got to have mass times acceleration to get any force. And I got lots of mass. I got this concrete dock here which weighs a lot, and that's my mass, but the tide doesn't give me very much acceleration, and so it just runs slow. So it's just the way it is. That's the reason this is the only one of these kind of machines ever built in the history of the world. If power, James Watt worked with a steam engine, and he says, how are we going to measure the power on this thing? And he figured what a horse would do. He thought a horse could lift 33,000 pounds a foot in 1 minute. He was wrong, but that's what he said they would do, and he called that 1 horsepower, and we still call it 1 horsepower. That's how we measure power. Now, the 33,000 pounds is easy. Each one of these floats, concrete floats, is about 7,000 pounds, and I estimate that these first 5 are working for me. Okay, so there's my 33,000 pounds. I got that. I don't have the 1 foot per minute. The problem with the tide is, on average, I'm running about 1 foot per hour. It'll go about 6 feet in about 6 hours on the average. So that's a 60th of a horsepower if you want to measure it that way.
How long is the tide still for?
Well, it just goes out and comes back. I mean, it gets to the top and then it just starts back down again. There's really no time. But what happens, about the tide, learning a lot about tide on this thing. Let's say on the average it's around 6 hours from low to high. And when it first starts, let's say when this goes all the way out and starts back up again, it goes really slow for a while. And then it gets about to the halfway, or about half the time, and it goes faster and faster and faster. And so through the middle, it's going as fast as it's going to go. And then it starts to slow down again, and it slows down to a stop at the top. And then it's going really slow, and then it speeds up. Yeah, like a pendulum. It goes exactly like a pendulum. And in fact, it is a pendulum, isn't it? That's where all my power comes from. That's moon power. Look at that thing go. Wow! You're welcome. You're welcome.